Welcome back, student. Now today we'll discuss about duct, which is very important in RSC unit, means refrigeration and air conditioning unit, basically in air conditioning unit, which is very important part of the distribution on the part of the distribution. Because as you know that air conditioning is basically a system in which the conditioned air is basically produced, that may be heated or cooled. Okay, now this heated air or cooled air means the conditioned air must be properly distributed from the air conditioning equipment to the room or spaces to be conditioned. Okay, and in various cases, and where the actually the air conditioning air is properly distributed or directly distributed the conditioned air from the room or from the air conditioning unit to room or spaces where to be air conditioned. At that particular condition, the duct is installed. Okay, so where the ducts are placed, because there are some air conditioning unit are there, you have to require in this space actually where you have to space to require to condition. Okay, air condition. Now for the difference of that particular region, you have to some amount of pipe or some amount of duct are there, so that the conditioned air is reached from the air conditioning equipment to the room to be air conditioned. Okay, so this is the duct. And what is the main function? The main function is to convey additional air from the air conditioning equipment to the proper air distribution. Okay, to the proper air distribution point. That means the air conditioning equipment are there, and the air conditioning air distribution point is such that where the air distribution point, so the air conditioning equipment to proper air distribution point or air supply outlet. Okay, or air supply outlet in the room, or carry the return air from the room back to the air conditioning equipment for recondition and recirculation. So its main function for the part of the distribution system where the conditioned air should be distributed through the duct from the air conditioning equipment to the room or spaces to be air conditioned, or from the equipment to the distribution point, or from the room to return to return the recirculating air from the room to air conditioning equipment for recirculations and recondition. Okay, and what is the cost? But means the cost of the duct means for the duct system is basically the cost of the total system about 20 to 30%. If the total cost of the system is 100 rupees, then the 20 or 30 rupees is almost cost due to the duct is cost. Okay, it is approximate that 20 to 30% distribution cost for the conditioned air are engaged. Okay, now classification of duct. There are so many duct are there, different types of duct are there. First of all is supply air duct. Supply air duct means this type of duct basically the conditioned air from the air conditioning equipment to it's basically supply the air from the air conditioning room to the space to be air conditioned. Okay, so this is called supply air duct. Return air duct means the air which is returned from the room to air conditioning equipment for recirculated and reconditioned. Okay, fresh air duct basically it flows the outside air. Okay, outside air. And low pressure duct, as you know that it indicates the low pressure duct. So obviously in this type of duct, the static pressure of the air in this type of duct, actually the static pressure is generally less than 50 mm of water. Okay, in case of medium and high pressure duct, in case of medium pressure duct, the static pressure of air is basically less than 150 mm. Okay, 150 mm of water. Now, in case of high pressure duct, the static pressure of air in the air conditioning unit or the duct is to be basically around 150 to 250 mm of Hg, means mm of water. Okay, so this is the depending on the pressure that created within the duct and the velocity Is it high velocity or low velocity? The low velocity duct is called where the velocity is less than 600 meter per minute. Then the low velocity, if it is the velocity of air is above the 600 meter per minute, then it's called high velocity duct. So these are the different types of duct, as you know. As far you know that. Now the question is in your mind that what is the duct material? The duct basically made of GIC, means galvanized iron sheet. Okay, galvanized iron sheet, and in some time also it is used for the duct material as aluminum sheet. Now you know that, I think all of you know, there are some difference with the sheet metal plate and the foil. So basically all these things are basically made of material, but in case of sheet metal to plate to foil, the main difference is the thickness. In case of sheet metal, the thickness is a medium. In case of plate, the thickness is higher than the sheet metal. In case of foil, the thickness of the metal or thickness of the thickness of the metal strip is basically very less. That is called foil. Now, it is basically made of galvanized iron sheet metal, which is basically galvanized iron means, as you know, that's obviously it's a iron basically are there. First is a galvanized means there are zinc coating up there. Okay, aluminum sheet also used for the duct material, but galvanized iron, as it is a zinc coating up there in the surface of the material, so obviously they will resist the corrosion resistance, because when the air is flow through the duct, so there will be contact with the inner surface of the duct with the air, so there might be chance for the corrosion resistance, means the corrosion effect. So if if it is made of galvanized iron sheet, so there will be less chances for corrosion effective. Okay, so for the galvanized iron sheet also used, but the thickness of that is 0.5 mm to 1.66 mm. Okay, but in some cases aluminum sheet also used because of its lighter in weight, and obviously it's low cost also. And in nowadays actually the resin bonded glass fiber are basically used, which use as a duct material, but it actually gives you the high amount of strength, and it gives you the easily shape. So that's why resin bonded glass fiber, and in some cases also wooden also act as a duct material where the moisture is not very important criteria. So all these materials basically used, but in general cases galvanized iron sheet or aluminum sheet, and nowadays resin bonded glass fiber also used as a duct material. Now duct construction very important, because when the air flow through a duct, so duct construction should be such that there is no leakage, and obviously there is no heat transfer from the system, means from the duct to outer periphery of the system, and either heat loss or heat gain is to be restricted, means that should be in adiabatic process. Otherwise the condition air will either heated or cool, either it can be heated or cooled depending on if it is heated or less. So that's why the outer surface of the material should be insulated. Okay, and obviously the duct construction should be such that the type, means when the duct are there are two ducts. Suppose there's a duct system, there one duct. So when they are joined together, so obviously there will be some joint, there will be some fabrication part. So they fabricated part or their joining part should be very it is to be riveted joint, and strength should be high, and leak proof joint, most importantly leak proof joint. Okay, so these things should be these things should be in your mind, that when you construct the duct. Now what are the duct shape generally? As you see, if you see in your any type of, say, AC system, air conditioning system, or any type of industrial air conditioning system, you can say that the duct are generally shape of circular, rectangular, square, or depending on that. But circular in economical point of view, if it is a circular duct, obviously it means that it flows high amount of air, because it's a cross section layer very much high, so it high amount of air, and obviously the less amount of surface. Okay, so if the less amount of surface means less ductile material is used, and less friction also are there. So circular is very economical point of view, circular duct is very important. In also rectangular, which is very important in case of rectangular duct material, in case of rectangular duct shape, it is very important because it gets smooth surface finish. Okay, but in practical point of view, square is very important. In generally, circular or square is very circular and square is basically used for the duct as a duct shape. Okay, but in many cases circular duct are mostly preferable. So all these things are basically introduction part of the duct. Okay, so what is the main function? You have to remind that what is the main function, what is the classification, what is the duct material, what should be the duct construction, and what should be the duct shape. So these are the point you have to remind that. Okay, you have to. Now the pressure in a duct. Now as you know that pressure in a duct, suppose this is a schematic diagram of air conditioning unit in which the air flows through a particular air conditioning equipment to conditioned space, or the air which is returned from the conditioned space to the air conditioning equipment. This is a flowchart diagram. You can say that. Now you can see here that this is the channel in which the air is flow through from the outside. So that's why it's called outside air. So this is outside air. Okay, this is outside air. Now it goes through outside damper. So outside damper used for the rectification of air or for the to clear the air. Okay, so now it goes to the filter basically used to filter the air. Okay, so after all, this air goes to the air conditioning equipment for the condition, for the cooling purpose or heating purposes of the air. Now after when the air from the air conditioning equipment, when the conditioned air is coming out from the equipment, it goes to the fan, so that the fan is rotating this cool air and then supply to the conditioned space to the supply air duct. So this is the duct. Okay, so these square section or circular section or rectangular section, there are various shape can be occurs. Okay, of the duct. So these are supply air duct. You can say these are supply air duct because through this channel, because as you know that duct has various types, because here it is called supply air duct because the conditioned air is supplied from the air conditioning equipment to conditioned space through supply air duct, means through duct system. That's why we call it supply air duct. So this goes to the conditioned space where the conditions to be air. Okay, now this is a supply air opening in which the conditioned air is supplied. Okay, now it goes to the for the conditioned space for to the comfort condition, to do the comfort condition. Now it again after some time it return the air, it goes to again air conditioning unit for the recondition and recirculating. So it goes via return air duct. That's why it's called return from the conditioned space to air conditioning equipment. That's why it's called return air duct. Now it goes. This arrow indicates in the red color. It indicate the flow of air. Okay, it goes to in this direction. Then it is return air damper again. And again it's mixed up with the outside air to the return air. It's mixed up. It's in this position. They will mix up the outside air with return air, and it goes to the again filter. Then it's totally recirculated the air and conditioned space. Okay. Now, to do this, main important thing is that within the duct there should be some pressure present. Okay, there should be present in pressure. Now, the pressure in a duct, basically it follows that the flow of air within a duct system is produced by the pressure difference. It is very important line. Just look at this. Look into this, that the flow of air within a duct system is produced. The flow of air within a duct, so this is the duct within a system, is produced by the pressure difference. By the pressure difference existing between the different location. If there are no pressure difference, air is not flow. Air will not be flow. Okay. So the pressure difference should be there so that the air should flow. So these are the pressure in duct. Now within the duct or within the air conditioning equipment or within the distribution system of air conditioning equipment, there are three types of pressure are there: static pressure, dynamic pressure, and total pressure. Static pressure, which is basically occur within the duct, because there is it doesn't depend on actually the movement of air. So within static, within resting condition, the pressure exists by the air within the duct, that is called basically static pressure, that is basically PS, and dynamic pressure, or sometimes also called also velocity pressure, because due to the movement of the air there is some velocity or there is some pressure will be generated. That pressure basically dynamic pressure. It is basically compensate with if the static pressure is reduced, then the velocity pressure or dynamic pressure increases. So in this way it is compensate. And static pressure is very important because there are some friction loss. When the air flows through a particular duct, there are some pressure difference, there are some friction loss will be occurred, because these are real practices process. So it compensates this type of process and maintain the pressure within the system. So static pressure main function is to maintain the pressure. Now total pressure means within the total system of the air conditioning equipment, the total pressure, that will be the summation of static pressure plus dynamic pressure. That will be PT is equal to PS plus PV, which is very important, because to flow the air within the duct system or within the air conditioning system, or we can say that so that the air conditioning air should flow from the air conditioning equipment to the conditioned space to be conditioned, or the return air should flow from the conditioned space to air conditioning equipment. So pressure difference should be present, should be there, so that the air flow smoothly and the air conditioning equipment working properly. Now again, as you know, air is a fluid. I know that fluid is two types, liquid or gas. Now air is also one type of fluid. So I think all of you have some idea that in fluid, from the fluid mechanics subject, that continuity equations. I think all of you know that continuity equation. Suppose these are the duct. This duct may be this type of shape, or this may be square section, this may be rectangular section. Any type of shape should be there. But we are assuming that these are the duct in which the air is flow through a particular duct. The section is 1-1. This is the inlet condition, and when the air or conditioned air is exit from the section, that section is 2-2. When the air is empty and the particular condition, that velocity is V1, and the data weight means from the free height, from the free surface of the to the duct, that is basically Z1, and section 2 height is Z2. Okay. Now, as you know from the continuity equation, it's basically for the conservation of mass. From that, the mass flow rate into the section 1-1 should be equal to the mass flow rate in the section 2-2. So section 1-1 in the M1 should be equal to M2, means M1 dot is equal to M2 dot. So that will be rho 1 into A1 into V1 in the section 1-1, section 1 in section 1-1, the mass flow rate, that will be rho 1 into A1 into V1. At section 2-2, the mass flow rate will be rho 2 into A2 into V2. And you know that, so the air is flow through a particular channel. If we assume that the air is density is constant throughout the duct system, then rho 1 is equal to rho 2, then it will be A1 V1 is equal to A2 V2, and you know that A1 V1 is equal to Q1 and A2 V2 is equal to Q2, because Q is equal to A into V. Q is nothing but is a discharge, or you can say that the flow of rate, okay, the rate of flow, okay, that is basically Q1, and that is nothing but A into V, that is area into velocity. Okay. Again, the duct system also we look like this one. So section 1-1 is the inlet section, this is the 2-2 section, this is the divert section. So it will be divided into two parts. This is the inlet section, this is the outlet section. It will be obviously M1 should be equal to M2 plus M3 from the conservation of mass. Again said that from the, if you apply the contact, because continuity equation is basically used as well as Bernoulli's equations, so all these things should be considered, and obviously there are some friction loss should be considered when you design a particular duct system within a for the air conditioning equipment or air conditioning system. So this equation, this formula should be used, this concept should be used, otherwise the air conditioning equipment doesn't flow properly, means air conditioned air doesn't flow properly. Okay, the pressure should be maintained properly, the continuity equation should be properly, Bernoulli's equation should be properly. So that's why the continuity equation, that is 1-1 section, here this 2-2 section, means inlet section should be equal to divided in two parts. So the discharge Q1, it will be equal to the Q2 plus Q3. Okay, it should be. Oh, these are the continuity equation. Next we discuss about the Bernoulli's equation for the duct. Okay. Now Bernoulli's equation for duct. As you know that it's all means duct follows the continuity equation. Similarly, it follows the Bernoulli's equations because air is basically a fluid. So as you know that for Bernoulli's equation, now if you apply that for the frictionless and incompressible and for the steady flow, if it is a duct, section 1 to section 2 is your inlet and section 2 is your outlet section through which the air is passed. Okay, so this is the section through which air is entry and this is the air exit from the section 2. Now from the Bernoulli's equation for the duct, for the frictionless, incompressible and steady flow, you can write this equation in terms of P by rho plus V square by 2 plus Gz is equal to constant. Now P by rho, I think all of you know that pressure head plus velocity head plus kinetic head datum head, it will be constant, okay, for a particular flow field. Okay, if it is a fluid is basically frictionless, incompressible, steady, then it can be written as like this way. Now P by rho, that if you rho is multiplied with the upper part of this equation, that equation becomes P by rho plus V square by 2 plus rho Gz is equal to constant. Now I think that P basically within this expression which is exists, that pressure, that is basically static pressure. Okay, that's why it designated that section. If you apply this equation in section 1 and section 2, so it can be written as PS1 in static pressure at section, for the section 1 it can written as the at section 1 the static pressure plus rho 1 into V1 the whole square by 2 plus rho 1 into G into Z1. So this is the total energy at the inlet condition. At the inlet condition when the air is entry to the duct. At the exit condition, the static pressure plus P2 into plus V2 by the whole square by 2 plus rho 2 Gz2. Okay, now if we assume that the density is constant, basically when the air is flow through the duct, the air density is constant. We assume that. Now rho 1 is equal to rho 2 and Z1 is equal to Z2 because this is the data meant from the free, if it is a free surface, a data standard surface from this side to the section height is basically same. So that's why Z1 is equal to Z2 and rho 1 is equal to rho 2. So in this way, so basically if rho 1 and rho 2 and Z1, Z2, if it is equal, then the equation becomes rho PS1 plus PV1. That means this is your rho 1 plus V1 square by 2, that is equal to your PV, means this is your dynamic pressure. So static pressure plus dynamic pressure is equal to static pressure plus dynamic pressures at the inlet and outlet section of the duct is same if the air is flow, or if we assume that it is frictionless, incompressible and steady flow. Then this equation also written for the duct, it is PS1 plus PP1 is equal to PS2 plus PP2. Okay, where PS1 and PS2 is static gauge pressure at the section 1 at section 2 and similarly PP1 and PP2 are your velocity pressure or dynamic pressure at section 1 at section 2. Now as you know that the total pressure or pressure in a duct, when you discuss that pressure in a duct, the total pressure is basically equal to the static pressure plus dynamic pressure. So it can also written as in this form that PT, that is equal to summation of PS1 plus PV1, that is equal to PS2 plus PV2. So PT is equal to this one plus this one. This both are equally same. So total pressure for the inlet condition is same at the outlet condition. Now, in actual cases or in reality, what happens that when the air flow through a duct, so there is some friction loss or occurs, so there are some pressure drop occurs due to the friction. So if it is accompanied or it is compensated with that, that equation becomes PS1 plus PV1 is okay, fine, and PS2 plus PV2 plus PL. PL is your pressure drop due to the friction or due to the other losses. If it is there are some pressure drop will be occur, that's why it's compensated with PL, because total pressure is equal to this one, this will be summation of this one. Now, but in case of what you see here, that pressure in a duct system, there are some fan introduced after the air conditioning unit when the conditioned air is supplied to the conditioned air through the fan. So if there are some increase, because fan is basically used to increase the pressure, so it is used as an inlet condition, because fan is used is your inlet supply, means in your supply unit. So it will be total pressure, that will be total pressure will be PS1 plus PV1 plus PTF. PTF is your, when you introduce the fan or blower, into the system that basically used to increase the pressure of the air. So that is basically your total pressure in the inlet section is equal to total pressure at the outlet section. So this is the Bernoulli's equation for duct. Now if you so V, as you know, V is your velocity. If the velocity of air is gives you in meter per second, and if you want to calculate the dynamic pressure, velocity pressure, that is PV, that is will be rho into rho A into V square by 2. Rho A means density of air, that is basically 1.2. Okay, 1.2 into V square by 2, that will be 0.6 V square Newton per meter square. Now if you convert into mm of water, millimeter of water, that will be PV will be V by 4.04 the whole square. In terms of if V is your meter per minute, velocity is give you meter per minute, then PV also written as V divided by 242.4 millimeter of water. So this is the Bernoulli's equation for duct. So this is a small interpretation for the numerical. Okay, so this is the Bernoulli's equation for the duct. It should follow. So obviously Bernoulli's equation and the quantity table should follow the duct, and there should be some pressure defined so that the air should flow through the air conditioning system. Okay, and obviously as you know that in practical or real cases, but there are some pressure losses, because when the air is flow, there are some friction occurs within the outside or inside surface of the duct. So there are some friction loss occurs. So when it will happen, there are some pressure loss. So when you consider when the air flow through a particular duct, there are some pressure loss or occur due to the friction or any other thing. So this should be considered. There are some other losses which has to be considered when you design a particular duct. So for today's class, up to you, and thank you very much for listening and watching me. And in the next lecture video, we will discuss on the pressure losses in duct. Okay, and we'll discuss on rectangular duct and circular duct and aspect ratio. So all these things will be discussed in the next lecture video. Okay, thank you very much for listening and watching me, and goodbye.